Hello and welcome back to Maths with Mr. Duffield. I am the aforementioned Mr. Duffield, and today, finally, you're going to have to excuse me because of all of the little bits of admin I'm doing on Teams and kind of dealing with quite a lot of pupils who aren't sure about how it was working, so going through emails. It's been pretty crazy, lots of training. So I haven't had the opportunity for like a couple of weeks to answer one of my Deps questions on this worksheet on sequences and series. Now, it is pretty straightforward fundamentally. They've asked for help with question 3. There's just a couple parts of this question that aren't exactly straightforward necessarily. And basically what it comes down to is just looking at the question and saying, well, I'm not going to be able to use the usual method for finding nth terms. I'm going to have to basically go a little bit off piece and just think about more fundamentally about the numbers I can see in front of me. So let's begin. I don't know. Let's do questions A, B, and let's do, I don't know, H and I. All of the others kind of fall within this pattern. But I'll start with part A. That is the sequence 1, 6, 11, 16 and 21. Now this is straightforward enough, isn't it? You find the difference and you will notice it's continually the same. It's the same, it's a linear difference. It's going up by 5 every time, making it 5n, and then you can go back to the 0th term, taking away 5, minus 4, 5n minus 4. That's just a straightforward finding the nth term of a sequence. The difference between every term of the sequence is what goes in front of n, and then the 0th term, the one before the first term, in this case minus 4, is what goes on the end. Part B, a little bit trickier. 3, 9, 27, 81, 243. Now, this just comes down to inspection. Really, you should realize and notice through just your general mathematical awareness that 3 is 3 to the power 1, 9 is 3 squared, 27 is 3 cubed, 81 is 3 to the 4, 243 is 3 to the power 5. So the position number of the terms in this sequence are the powers applied to the base 3, making the nth term 3 to the power n. That's it. That's part B. I mean, effectively, what it comes down to is just getting used to what the square numbers and cube numbers are of different bases. And unfortunately, that only really comes down to practice. Let's look at part H then, skipping forward. 1 over 3, 2 over 5, 3 over 7, 4 over 9, and 5 over 11. Okay, now, what I tend to do when I've got fractions like this is pay attention to the numerator and the denominator and relate those to the position number. Let me explain what I mean by that. The numerator of this fraction is 1, the numerator of the second fraction is 2, the third fraction is 3, 4, 5, and so on. They're going up by 1 every time. So I can effectively express the nth term as a fraction, where the numerator in this case is n, the position number. I hope that makes sense. And then 3, 5, 7, 9, and 11. Well, that in and of itself is its own little sequence, isn't it? The difference between is 2, like 2n, and then the 0th term of this denominator sequence is plus 1. Okay, so let's give this a go. First term. If n was 1, well, the numerator is 1, the denominator is 2 times 1 plus 1, 3. The third term, 3 over 7. If n was 3, then the numerator is 3, and the denominator is 2 times 3 plus 1, 7. Seems to work. So effectively, when I'm dealing with fractions like this, I treat the numerator and denominator as if they were their own little sequences. Do the method as I did for part A of this question, to the top half and the bottom half, and just make a fraction out of it. I hope that makes sense. The last question I'm looking at today is I. 1, 3, 7, 15, and 31. Now, this one, a little bit tricky. Let's take a look. It's +2 between 1 and 3. It's +4 between 3 and 7. It's +8 between 7 and 15. And it's +16 between 15 and 31. These differences are going up in powers of 2. So this implies that the nth term is some version of 2 to the power n. Okay? Because those differences are continually doubling, it's a base 2 to the power n. That's the sign, that's the kind of signal that tells me that is going to be part of the algebra. What is 2 to the power n? Well, if n was 1, 2 to the n would be 2. If n was 2, it would be 2 squared, 4. If n was 3, that would be 8, and then 16, and then 32. Are we noticing anything about the 2 to the power n values and this sequence? You should be noticing something consistent between them, and that is every single term has 1 taken away from it to make my sequence. So 2 to the power n minus 1 is going to be the nth term of this sequence. Okay, I knew it was 2 to the power n because the differences were continually doubling, implying a base 2 to the power n, and then I look at the actual values of 2 to the power n, compare them to the sequence I've got, and if I need to do anything, in this case take away 1, that goes on the end. So, nth terms, going into slightly more complex stuff. I hope that answers some of your questions on it. You should, I'm hoping, be able to work out any of the nth terms from that question based on this instruction. Have a wonderful day, keep working hard, and for goodness sake, get your work done on Teams. I will talk to you later.